But yeah, thank you so much for joining us, Maxim. I was so excited to meet you and chat with you. I just mentioned to you that we've taken so much of the engineering philosophy you guys have put out to the ether to inspire ourselves and like the way we think about durable execution and these like very durable pure functions. I was really excited to give some context to the audience as to your background and origin story and what was the arc that led you to Temporal. I saw that you studied in Moscow and then in Rio de Janeiro. What has that path been from studying physics to becoming CTO of Temporal?
Okay, story of my life. Yeah, thanks for having me. It's interesting. I always was in physics, in mathematics, and in Russia we had it's Soviet Union actually. Like
Hmm.
we had this pretty advanced system of teaching kids math and physics. So we had advanced kind of classes and schools,
Yeah.
and I was in one of those schools since eighth grade, and I kind of logically ended up in Moscow State University doing physics kind of doing nonlinear optics. I forgot all of that by now, but back then, I think the main thing it taught me is kind of thinking from first principles. Just kind of like, in physics, you kind of decompose the problem to the kind of most basic axioms, most basic rules, and try to kind of, okay, this is infinite mass, what will happen? Oh, this is zero mass, what will happen? Kind of try to kind of break system into components. And then by kind of chance, practically ended up in Rio de Janeiro and ended up doing what I was always like to do is computers. And it was 1995. So, and I did my master degree like in computer science there. The funny part was that my first course was practically in computing in general. It
Oh,
was
interesting.
object-oriented databases. So I kind of started like from the top. Then yeah, and then data structures were like third course I had. And after Brazil, we actually had pretty decent internships there. So we worked in telecom and on a very large C++ code base and like over a million lines of code. So I saw some pain doing these type of systems. And then in 98, I moved to the US. And initially I worked in a big AT&T in New Jersey that was like that original AT&T, like Bell's Lab one.
Yeah.
And so I didn't stay there for very long, but it was pretty interesting experience as well. I ended up in Seattle and I've been living in Seattle since 1999. And I worked for a startup here in Seattle. Nothing super interesting besides there was dot-com bubble. I, I wrote some interesting pieces of software there. For example, I wrote generic translator of any data structure to any data structure. And
Wow.
you could practically, I don't think anything like that exists really because you could practically write more like functional language. I invented it kind of, which was like Java syntax like functional language to map any data structure to any data structure reliably with like proper error handling and like it was kind of cool, I think,
Well,
for
that's
the
very
time.
interesting.
And as part of that, I also wrote like EDI translator, like things like that. But then I ended up after the startup went under, I ended up at Amazon, and it was 2002. The Amazon was already a pretty established company, but back then it had 800 developers, which by this time was looks tiny.
Yeah.
And Amazon was going through transition of from this huge monolith, which was taking 45 minutes to compile just to relink. And I think all compilation was 18 hours, I think, something like that,
Oh,
on the
interesting.
high end machine to services because just wasn't practical to maintain that thing. And so I saw all of that from the beginning, how like you do services. And I ended up in a platform team. So they called Splat, software platform. And it was well before AWS was conceived. And I ended up being tech lead for the Amazon messaging system. Practically, Amazon pops up and I helped to design the replicated storage for PubSub system. It was well before Kafka was kind of conceived.
Yeah.
And whole Amazon ran it for years. I don't know where they are right now. And at some point, Simple Queue service was developed and they took it as an engine. So Simple Queue service used it as a backend.
That's so interesting.
And the interesting part is that as somebody who was practically tech lead for the PubSub of Amazon, I talked to almost every team which used that for interprocess communication as we were moving to these hundreds and thousands of services and trying to orchestrate them through queues. Our team clearly realized that it's just not the right abstraction. It's two-level abstraction. So queues and PubSub and event-driven systems are just not the right way to build distributed systems. So we started to think how to fix that. We decided that we want to do some orchestrator,
Yeah.
and we had multiple iterations internally, but the public one, kind of the one I was tech lead of, was simple workflow service. And the simple workflow service introduced quite a few cool ideas, but we never nailed a developer experience. That's why probably most of you never heard about it. But step function, I still think, run on that as a backend. So it kind of we had to build it as a very scalable AWS style backend.
No, I'm just fascinated because I start seeing the themes that led you to build Temporal in a way, just looking at the challenges that you faced from PubSub being the wrong abstraction to build something on a distributed system, like using events, and then thinking about it from a workflows perspective. Like I can start seeing the lines that got you to start thinking about Temporal. Or maybe, what do you think? Am I getting this right or not?
No, you're getting it right. I think one kind of point there is that PubSub is not run abstraction in the sense of runtime. You want an asynchronous event-driven system at runtime because they have much better characteristics than synchronous systems at runtime. So you can have services which are down, right, and your system still doesn't collapse, right? You have rate limiting, flow control. So there are a lot of good things about PubSub. It's just not right abstraction for developers. It's just low level and makes your life harder. And so it means that if you're building something like orchestration engine, you want a system which internally is fully asynchronous and uses PubSub internally. It just shouldn't be the abstraction which you give to developers. It's like the same thing. Like it's
Yeah.
good to have like physical memory in your machine, but you probably or like pointers. But ideally, you give them system which they don't need to care about those things, right? You just use garbage collection, at least for application level development.
And you were talking about UX earlier, right? When you talk about, for example, memory, I keep thinking this has been through my mind a few times this week, how the shift that Apple made from forcing iOS developers to think about memory and memory allocation to abstracting that away with Swift and garbage collection is what exploded really the App Store in a way, because the bar to build an application just lowered so much. As much as I can claim I was taught how to malloc in college, I would think that if I'm also building a like application that is like pretty large scale, it does get progressively really, really complex. It's too low level, to your point. I'm really wondering, do you think that this like necessity for user experience and for the surface area of durable functions, do you think that was one of the influences behind starting Temporal?
Absolutely. Because what happened is that when we did simple workflow, the first version of that was mostly about service-side APIs, right? You can think about simple workflow as a distributed event loop. If you think about it, it's practically how do you distribute work across multiple worker processes, but in a way that you can kind of make sense out of that. So it had this notion of event history, and you could kind of so it's about distributing work. But the developer experience, initially I obviously did what everybody did, right? I kind of okay, I need to build something to specify long running computation reliably. How do you do that? Everybody, okay, you do a graph, right? You do kind of syntax tree, abstract syntax tree. So
Yeah.
you design something which is either DAG, or you have this kind of, okay, this is an activity, this is sequence of activities, right? This is the kind of if else like conditional branch, right? Like it's
Yeah.
just like, oh, this is parallel branch. Like you kind of just design this thing, and then you could. We didn't do visual, but we did it kind of what people call in code, which is not really code because code was instantiating these objects, right? And this works, right? Like the whole industry still kind of a lot of people still use that, and it's funny to watch AI people kind of reinventing this thing. Like again,
Absolutely.
like most of these frameworks like end up doing graphs, and which is I think is a huge mistake. But I did it myself. Well, I don't think it's a mistake because somebody told me so. Because I wrote framework, it was actually in production, it was good enough, but it was so ugly. I just kind of felt that I don't want to be there because the moment you kind of start looking at this type of graph-based framework, you kind of realize all the issues, right? First, it's just a lot of boilerplate code. Second is that things like it's all about not about sequence of steps, it's about data which flows between those steps. And graph obscures that, right? Like most of the frameworks out there, they just have global bag of things. And what is global bag of things? You have no clue which part of your graph modified that bag, where the variable was inserted, where it was consumed, right? Like everything is global, and everything is hash mapped. And it just makes your programming experience awful. And then every condition, like you need to invent how to do conditions, right? Like you practically need to use some language. Practically trying to kind of take like normal code and convert it to this. And then and it wasn't immediate, but at some point, like I'm like, okay, why we just cannot have code? Why I cannot just write normal Java code, Go code, Python code,
Yeah.
which implements my logic and still have all these capabilities? And this is how the idea of durable execution was born: is that you just preserve the state of code, normal code. You don't need to convert code for some graph. You don't need to convert code to something else. You just preserve the state of code as it is.
I think that makes total sense because
Yeah.
you're decoupling the flow of the information, the execution from the actual business logic, right? And I think when I see myself included, to be honest, people building today AI applications that rely on these feedback loops or iterations or agents, for example, where there isn't a clear pattern for how to actually orchestrate these workflows really well. I actually have seen the like if else, if else, if else, or the switch case statement of like, hey, I design a state machine by means of just having a switch case statement with 15 different cases. And, the machine is at whatever state it needs to be, depending on where the branch is being executed. And I think Temporal is a really interesting way to think about running business logic in a way that the code itself is not coupled with the philosophy of where it executes and how to distribute it. I wonder if you guys have felt that existing tools, you must have seen throughout your career, whether like DAGs and queues and state machines and graph fall short. Why do you think, is there a threshold at which things start falling apart? Right? Like, is there a threshold at which you want to start thinking about durable functions? Or should you start thinking about durable functions from the start of the project?
I think before that, we probably need to explain what durable execution is, right?
Let's talk about it.
Yeah, because I think maybe some people don't know about that. I think about durable execution as a crashless execution. Imagine that your code cannot crash. So just process cannot crash. Some magic keeps it always running. So there is guarantee that your machine will never go down. You would write your code very differently, right? Like as we had some presentation saying, okay, imagine like you were at school. You wrote your first program and it was all good, right? And you liked it, but then you need to completely rewrite it and throw away almost everything because you had to run it in production and make it reliable. And imagine that we have runtime, which allows you to practically provide that guarantee. In real life, what happens if process crashes? We will just take that state of your program, transfer to different machine, resurrect in exactly the same state, and continue from where it was left off. So it is kind of live migration through persistence. So it means that that's why it's durable. But from your point of view, program just keeps running, but it's not linked to a specific machine. This is the power of it, right? It's just code which keeps running in presence of any failures, as nothing happened. So in worst case scenario, it can be delayed if you depending how long like recovery took. But in all practical situation is that you make for example, it makes very interesting implications because if your code cannot crash, then you can write a function which runs for a year, for example.
I see what you're saying. You can
Imagine
start.
you want to do subscription. How would you model subscription? You can write a loop and say for like from 0 to 12, sleep 30 days, charge credit card, send email. Obviously, it won't be 30 days. You need to recalculate it every like months, but conceptually, you get the idea.
Yeah.
And as this cannot crash, you can actually write production code like that. And try doing that. And if you count that with like 10 lines of code, and now do it any other way. And then, okay, now do it for million subscriptions or 10 million subscriptions. And if you have runtime which can support 10 million of those functions running in parallel, as an engineer, don't need to do anything. You just write again 10 lines of code.
Yeah. No, that makes total sense. Why do you think, I'm really curious, why do you think modern distributed systems need this today?
Because this is exactly what, as you said, like because they're distributed. And every developer these days is distributed system developer. Okay, there are some people doing like IoT devices. Even those people need to like build distributed system to support. No IoT device right now is just like sitting by itself. It talks to the cloud anyway. So, but in general, we are all distributed systems developers, and distributed systems, the main assumption that everything can fail anytime, right? Any machine can crash, any network connection can go down, right? And so like we can get outage of the whole region, right? Or even cloud provider. So you kind of need to deal with that. And you as a developer spend most of your time making your system reliable. And most of your code is about, it has nothing to do with business logic. Like just the example I gave about subscription. Imagine how much code you need to do to actually provide like production quality system to do subscriptions for like 10 million users
Of
and
course.
guarantee and account for failures of charge taking a long time because maybe it requires manual approval, account for failures and again send notification, account for failure, making a durable timers because you need to wait a day, so you need a cron job or whatever to scan these records, database for persistence. And because it's durable execution, you need persistence. You just store stuff in local variable because again it's durable, so you don't
Yeah.
need to explicitly talk to the database. Or your API call can take any amount of time. You call sleep 30 days, it's a block and call for 30 days, and it's normal, right? It completely changes the way you even think about the problem. And why you need it? Because it kind of completely abstracts out so much complexity of distributed systems, so much complexity of failure, right? That you just can focus on your business logic. And then that's why you practically become 5 to 10 times more productive because you just focus on your business logic. And you need to reinvent the wheel of reliability and resiliency, which is like almost every application.
The way that you just explained it to me as an engineer, my first reaction or the first value that I give to this is in state management, right? The idea that I could store information in a local variable as opposed to think about how to persist the state of a subscription that I need to check on 2 days later. That's probably the first thing that is very shocking to me. Almost too good to be true, right? Like the more traditional way of doing this would probably be to rely on some persistent storage and rely on that persistent storage to continue sort of executing upon these functions, hoping that, well, if you have a distributed system, that things don't fall apart and that the sharding has been done correctly and that you are storing things where you should. Is that, am I in the right direction? Do you feel like are developers seeing value through, for example, state definition and then sort of tracking state across a function?
I think it's all together because there are, for example, object relational mapping frameworks, right? So there are frameworks which will give you impression that some field is durable. So when you access that, it will read from database. When you update it, it will write to the database. So I think if you just give it to people, they kind of don't understand the difference. The biggest difference here is exactly that your API, it's preserved through execution of your function.
Yeah.
It's not just callback which returns. And this function can block as long as necessary. I think this is the interesting part is like, because this function itself can run for a year without exiting, without like completing. Because any other computation requires breaking this into the pieces, right? Like
Of
if you do
course.
event-driven programming, how do you do that? Oh, I get callback. Callbacks load state from database, updates the state, saves back, publishes another message. Oh, by the way, there is race condition there between publish and message. Oh, I need to use outbox pattern, but it has other problems. So practically, you kind of need to start thinking about all these edge cases, and you need to think about state management. And here it's all in one package. State you don't need to manage, but at the same time, you practically have the function which can run as long as you want, and you can block on anything like most basic thing, durable timer, sleep 30 days. Think about how powerful it is.
Yeah, I mean, the way that I can only think I would do this without a durable function would be to have this like doom scenario with 50 different lambdas that you execute on different timers and then pass it on to the next lambda, and then it needs to read from state. So I totally get it. I mean, I think
I actually had a real example of that is that one of my friends, he was learning kind of cloud programming,
Mhm.
and he got a book about one of the kind of clouds. And practically the beginning of the book is like, imagine this use case. For example, you have Twitter and you want to send, for example, look at Twitter field like every 15 minutes and generate summary, like do some manipulation, and then like send you email with summary or something like that.
Yeah.
And I had very nice diagram which had like 5 function, 3 databases, 4 queues, another service, blob store, and like, and the whole book was about explaining how to run the, like produce that thing. And I'm like, okay, good, like come here. And I just brought up my ID and I wrote the whole thing as a single workflow, practically using our SDK in like 15 minutes, end to end. And it was like probably like less than 2 pages of code. And he looked at that and like, what?
I
I
can
don't know
only
if he ended up
imagine.
reading the book, but yeah, I think this is exactly like changes completely. You practically eliminates need for all that complexity and just makes your life as an engineer so much simpler because you can just write normal code and we have like 7 SDKs. You want to do TypeScript or Python or Java or Go or even PHP, right? Or .NET. We support all of that. And you just write logic and you don't think about all these pieces which you need to stitch together.
Yeah, these pieces around your code were not providing necessarily pure functionality per se. They were just patches to be able to do something that you can't do. So, no, I totally, I think it makes sense. And I could see how, I mean, I imagine, have you guys felt any curve, like in terms of user education when you talk to developers, as like how to shift a little bit their gears? Because I can assume, even from my perspective, um, the first thing I would think about is, got it. I got a bunch of lambdas, and I gotta send them messages between them and persist the storage and do all these things. Have you guys felt any friction with developers and like kind of changing their mindset a little bit?
I wouldn't say friction. Once people learn about that, they want to understand that. But it certainly requires kind of mind shift, right? It's pretty common for me to be on a design session with some user of the technology, like new user, and they're like, okay, here's our system. How do we kind of connect Temporal like to, for example, our existing architecture, which uses a bunch of queues? And the first attempt is usually just put temporal in every node of that graph they have of queues. Like, okay, what happens if I get messages? How do I process them? And they're like, yeah, you can do it, but did you think about what publishes this message? Like, because they always start like, oh, I get these messages. How do I process them? And like, fine, you can process them out of order, because state management is much easier here. But what publishes those messages? But it doesn't matter. No. But let's talk about what publishes those messages.
Yeah.
It's another service which does blah blah blah. But by the way, what publishes those messages? And then like, but what's the use case? And then we kind of talk it through. In reality, is this use case and all this architecture can be replaced by usually like 50 lines of code, which just performs their business logic. And then it's mind blowing. But like it takes time for you really realize how you need to rethink your completely approach to the architecture. And still, it's mind-boggling to me that most people still didn't know about that. They still kind of think queues. They still think DAGs. They still think like it just it's education. Yes, more and more people know about that. Once they know it, they cannot go back.
Yeah.
The
No,
best adoption of our technology always was people moving around the companies. Like
interesting.
yes, and the best one obviously when we get like new shiny new company, and then like there are multiple people come from different companies which used it before. Then our adoption just goes extremely fast, just because everybody they just cannot go back. They just cannot go back to the old ways.
And I think makes, I mean, once you've tasted a new texture for software, I could see how it's a lot easier. And I could totally see it. I mean, I have to empathize with some of these engineers who are like, well, what do I do with this Redis whose only job was to track state across runs of different lambdas for this, like, it's just spontaneous almost or ephemeral state management, right? That makes total sense to me. You mentioned multiple languages. I know you guys have talked about polyglot workflows before. I would love to hear from you. Like, have you noticed any major trends in multi-language systems and how you guys approach this?
I don't think there is any like real trend besides that most companies have used more than one language,
Yeah,
and, for all sort of reasons. A lot of people do AI in Python because everybody does AI in Python. A lot of people write Go. They have legacy system and whatever, and then like enterprise uses Java. A lot of people use .NET,
yeah,
and I think in a lot of places it's just table stakes. Unless you support these 5 languages, we are not going to like even consider you for company-wide kind of solution, because what do we do with the other languages? And one thing I want to just kind of make sure that you can adopt Temporal in one little place. You can adopt it for single function, which is part of your service.
right.
But what happens is after you learn these kind of new ways, it kind of organically always grows to beyond a single service, beyond one team. And at some point, people just want to link all the service in their company using this technology. Because especially right now, we introduced this new technology called Nexus. Think about Nexus RPC. So think about this world right now. You are either you're in the world of services, and there are practically two kind of stages or two approaches. One is RPC, right? You make synchronous requests, And they have all sort of issues with availability, right? And like you cannot have long requests, and then you need to deal with retry. Like there are all sort of availability problems. And then you say, okay, now I need guarantees of execution. Now I need to make sure that some requests can take long time. Then we're saying, okay, forget about request reply. Now we are going to async, right? Now we are event driven. Now we put queues. Now everything, no APIs anymore. You cannot have service API because your service API is 50 queues in and 5 queues out. And it's a complete mess. And what we are saying, okay, what if you can keep RPC paradigm on development level, but your RPC is guaranteed to be executed and it's delivered, and it's guaranteed and it can run as long as you want. You want to take it 50 milliseconds, fine, but if you want it to run 5 days or 5 months, it's still an RPC. Your caller can wait for that, and again, using durable execution, you can block as long as you want, and your function which implements it can run as long as you want. So practically, you can have a normal service, RPC vault, but behind the scenes, all asynchronous event-driven queue-based. But as a developer, you just get RPC. And this is a very nice model, and this is what we are doing. That's why we kind of go beyond single service right now, practically replacing the whole architecture of your company with this durable RPC, which we call Nexus RPC. And now what we are trying to do is kind of see, okay, can we extend it to the MCP vault? Because tool calling right now is not reliable, right? Like there is no really good way to call a tool which takes a day, right? Like people and models don't understand like events very well, right? Like they understand tools. Oh, I want to call this thing and get a result. And from the model point of view, there is no difference if this takes 5 milliseconds or take 5 days, because it just wants to get the result of that computation. And Nexus plus MCP practically give you that, because you invoke it and model waits there, waiting like as long as necessary. Your agent waits. 5 days later comes back, we resurrect in exactly the same state, give it back to LLM, and it continues from where it was left off. So practically, you can automatically make your agentic framework durable and support long-running tools without practically doing any changes to your code.
That makes a lot of sense. And that was actually going to be my next question, which is where do you see durable execution fit best in AI agents and LLM pipelines? And it seems like the first thing you mentioned is this idea of tool calling and tool calling discovery, like MCP. To me, it seems like pretty like the value proposition of Temporal seems, and I know you guys have been working on this for quite a while, but with the advent of AI and sort of asynchronous tool calling, it seems like Temporal as a value proposition and as a philosophy is just like 10x more valuable, to be honest, because these inference and the resources we use for inference are notoriously unreliable. And I don't know if you felt like you guys have, I mean, have you guys felt a wave of like people using this for AI agents, MCP, LLM pipelines?
Oh, absolutely. Well, our adoption in AI world is insane.
That's
And
fantastic.
and it's kind of interesting because if you talk to average person in AI world, they probably never heard about us.
Yeah.
But I wouldn't be surprised if we run more enterprise AI workloads than any other company. Just because people who know about Temporal, and like everyone who knows uses Temporal, we have thousands of customers already, and like hundreds of big corporations using us. Everyone starts doing AI. Everybody doing AI right now. And practically everyone who's using Temporal just doesn't think. They just start using for AI without thinking, because this is the best technology for that. Now, obviously, more people who are just purely AI never thought about reliability. Some of them don't know about Temporal. They kind of go for this kind of legacy approaches, which is like, okay, now we are going to do graph. Because think about it, it's not about just tool calling. If you look at any agentic application, it is a workflow, right? They call it orchestration or whatever. But okay, it can be non-durable. Maybe if you're just running, for example, inside of IDE and you're doing stuff, the moment you do that is if it crashes, okay, it doesn't matter that much, right? Like you can just redo these things. More and more people move that to the actual very scalable and like pipelines, which you want to guarantee execution, especially when agents not just take information, but actually take action. And this is exactly where people use Temporal, because in this case, it's not only about calling tools, it's about the whole thing. And if you think, what is agent? It's a very simple idea. Like it's just you call LLM, it tells you what to do. It's a dynamic workflow. You call tools, then you get information back, you call agent again. And then maybe you have some kind of business logic code, which transforms these outputs to some other information, calls some other databases, then composes your context and calls another LLM. But if you think about this end to end, it is always a workflow. But again, workflow from temporal point of view, because if you try to represent it as a DAG, which some people try to do as a graph, you end up with a mess, right? Because any non-trivial example is just, like as I said, the same problem. So it's not clear what it's doing, and like data, like it's just very hard to represent complex things because it's just the only way you can do it in code. And so that's why I think temporal plus agentic applications is just somebody told this actually. It's a killer app of durable execution. Agentic application, a killer app of durable execution. I 100% agree with that because we've been around. People use us for everything, right? From like infrastructure automation, like if you think about Datadog backend, all orchestrated by Temporal, right? Like HashiCorp Cloud orchestrated by Temporal, but then go up the stack, data pipelines, all the ingestion of data and processing of data for agents is a lot of people use Temporal for that. And then you go business flows, right? Like customer onboarding, payments, instant payments. But now, like with agents, it's actually kind of all comes together. And I think this is the very exciting time for us.
I think it's almost poetic that you guys have been working really hard at this for like, I think it's like better part of 6 years almost, I think. And
Yeah, much more.
much more than 6 years.
So if you think from simple workflow times, the public version is a third version. So this is like 15 years of development practically. And actual code base we are running right now, it started at Uber almost 9 years ago. So think about it, it's like code base is 9 years in production at large scale by thousands of companies. And it's open source project. One thing we didn't mention, it's MIT licensed open source project, right? It's fully featured. A lot of companies, for them I mentioned Datadog, 100% running open source. It's open source and it's been in production for a long time. We also have commercial offering when we run backend for you, but if you don't want to deal with running backend, there is open source backend you can run yourself.
No, and I think it's poetic that now, after so many years working on this, there's this like killer new use case that is kind of the perfect fit, to be honest with you, because I feel like, I think to your point, what I see a lot of people doing in the industry, we're an AI company ourselves. So a lot of our network is people building things on top of AI. And I think there is this stochastic nature to these functions that we run. And I don't think people see them as stochastic. They just almost expect certain guarantees without actually working for them. And that ends up biting a lot of people when they build things that are really complex. And to your point, if you're just running Cursor or like a Code Copilot, I think that client-based applications, it's easier to sort of retry and sort of find the code is the state and the conversation becomes part of the state and part of the context. But for instance, for us in BEM, our customers are enterprise, like this is like financial services companies. If they call a function within BEM, it needs to run and it needs to have like there needs to be a guarantee that it will run and it will just crash. And so I think it's become, to us, that's been one of the biggest challenges, to be honest, like that shift in mindset, perhaps, of, hey, a lot of AI applications today are built. And I think it's because a lot of AI researchers are probably not thinking about the infrastructure.
No, I think it's logical because think about it. First, you solve the most important problem. Most important problem, the AI producing actually meaningful results.
Yeah.
Right. Like, why would you care about durability and availability and like guarantees of execution when your LLM just produces garbage, right?
Yeah.
But we are getting to the point that they're actually getting good.
Yes.
So we're actually becoming useful. They're producing good results. And we are kind of slowly seeing people, okay, now we produce something, we have something of value, create pipeline, which like useful. And then they're like, now we need to put it in production. And then when you start thinking about production, then like these concerns become, and some people, oh, it's afterthought. Let's try to, it doesn't work like that. Like, it took us 15 years to get where we are.
Of course.
And it's very hard. I think everyone who tried to build their own kind of workflow engine at scale knows that it's non-trivial. And it's like reinventing database. You can probably write your own SQL database, but why would you do that? And we are kind of in the same category. We are new middleware, not using middleware, but doing your own. It doesn't make sense. By the way, even coding agents, think about it. When an ID is one thing, but we are getting more and more of these agents like which are doing it in background, right? You ask it to fix pull request, like bug, and they create pull request. For example, OpenAI Codex uses Temporal to
Great.
orchestrate, right? So it's based on that because they want to guarantee that because it's a very long running process, right? It calls a lot of tools, performs a lot of function, you really don't want that thing to fail in the middle. That's why they use Temporal for that.
And I think it makes total sense, especially the one thing that you mentioned that I would love to hone in on is it's a long running process. And I wonder if that is why one of the very simple reasons why durable execution makes sense in the age of inference is that these are not one deterministic function calls. This is like a long running sort of execution that is very probabilistic and very stochastic. Do you feel like, from a very simple standpoint, that is one of the enablers?
Yes and no. I think there is one kind of caveat there because people tend to kind of put things, box things into the boxes, right? Or temporal is for like durable execution for long running processes. Yes, it absolutely works for long running processes. But there are a lot of most workflows which run in temporal actually under 1 minute.
Very interesting.
And why? Because it's not about how long it runs. It's about guarantees.
Yeah.
For example, why would you use temporal for instant payment? For UPI, for example, in India, or like Brazil has similar system. People use it for that. You know why?
I don't.
Compensations, because you need to guarantee that these things either completes or even if it fails, you get error back. We need to guarantee compensations because there is no transactions across multiple banks. There is no transaction between multiple services. So you need to run Saga, right, pattern when you run compensations. So with temporal, you can return error to the user in milliseconds, but then run compensations if something is down as long as necessary. So it's fast enough to be interactive. So you absolutely can do chat and like things and like press a button, get reply within milliseconds. It's not about, again, long running or not long running. It's about, do you need guarantees that if something fails, certain things will happen. And things can be even error to the user in compensations, or you can do forward recovery, just submit the request and say will come later. But the point is that it's not like, oh, if it's less than 1 minute, don't use it. No, absolutely. There are 1 second workflows all over the place because, again, instant payments should be fast. So, yeah, so it's not about durability. But obviously, longer you run, more probability of the failure is, and more care about that. That's why certainly all this agentic stuff right now, especially as we are getting to the agents, like what we call durable agents, like which need kind of persist for a long time and take real action, right? Like run on cron, check things out,
Yeah.
react to external events. Those are just bread and butter of this durable execution.
No, and I totally it totally makes sense that you guys the focus on the value proposition of guarantees of execution, and regardless of the length of the process, right? Actually, you brought up an interesting topic. I'm really curious, in your opinion, when does it not make sense to use temporal?
Kind of, it's very simple when you don't care, right? So when you don't need guarantees,
Yeah.
when it's okay to return 500 and leave your like state in an inconsistent state, or it's read-only operation,
Yeah.
for example, right? You're rendering the web page. Okay, you don't need temporal to render a web page. You can just not render it, return 500, or render it partially, right? But you can again, if failure doesn't matter or failure doesn't need to be recovered, then you don't need temporal. There are some other scenarios mostly related to performance. For example, temporal is not good to just crunch data, right? Like if you need to just take like, I don't know, 100 megabytes of log files and convert them, you can use temporal to orchestrate that pipeline,
Yes.
but you're not going to create workflow per record and like that. But at the same time, for example, if your batch job involves calling services, which can fail, right? And each of them can fail differently. Then it's actually people do a lot of batch jobs with us. For example, end of months, I don't know, statement generation,
Yeah.
right? Very common scenario with temporal because there is failure in there. It's not just crunching numbers, it's not just like training, but pushing it through GPU and so on. But if you need to kind of orchestrate tasks, if you need distributed system, if you need guarantees of execution, if you call other services, if there is some unreliable component and you need retries, you need to kind of flow control and so on, then temporal is a very good fit.
No, I think it makes total sense. I appreciate the differentiation you made that, well, You don't need it if you don't care. That's obviously one. And I'd be surprised to see how many people maybe don't care because they don't know about it, like they haven't, their eyes haven't been opened yet. But I'm really, you touched upon earlier something really interesting, and you mentioned you don't need to have temporal everywhere in your application. Like you can select certain functions to be durable functions, and you can select others not to be. And I wanted to touch upon this idea of composable infrastructure. Like, have you guys thought about this from that perspective? Like, do you feel like the future of building systems feels more like these composable infra pieces where some of them are durable and some of them are not? Maybe you have a function crunching numbers that does not need to be durable, but the services being called need to be durable. Is that how you guys are thinking about it?
Yeah, again, infrastructure is kind of loaded term, right? Like there are different ways to think about it. But one thing which we are doing with durable execution, we actually abstracting a lot of infrastructure, right?
Yeah.
And not only infrastructure on the level, oh, is it this type of database or that type of database? For example, you don't need database at all in most cases because you just store it in local variables. Yes, we use database internally, right? There is no magic, right? Temporal requires database. Open source runs on MySQL, Postgres, or Cassandra databases, for example.
Interesting.
Recently, somebody added Yugabyte binding, right? In our cloud offering, we build our own database, which kind of can scale much better than any open source one. But as a developer, you don't know about which database we use, and we can switch database without you noticing because there is nothing database specific in the code.
Yeah.
The same thing, we use queues internally. So when you invoke an activity from the workflow, we actually put task in the queue, and a worker which implements that activity will pick it up according to flow control and all the other things. But as a developer, you make an RPC which takes 5 days. We are not going like there is other route. Oh, we will give you queue interface, and then we'll create this magical queue interface which works with any queue. And these are very leaky abstractions usually. Or we will consume like general queue consumer, which works with both Kafka and RabbitMQ, for example. But you will miss half of the features, right? And we are saying, no, you don't even see the queue. You just make RPC. But internally, it has it. So there is this part. And you don't need to think about crashes. You need to think about specific processes. You don't need to think about queues, databases, because you just program on a high-level abstraction.
Yeah.
And that is kind of one thing we do. The other thing is that people use us to implement those type of solutions, right? For example, I mentioned like HashiCorp, right? They kind of orchestrate Nomad clusters, orchestrate the infrastructure using that. And it's kind of interesting. They had presentation at our conference, and they do interesting things. They, for example, run Terraform as an activity from a workflow, but at the same time, they make workflows a resource because you can have long-running workflow, which is always running, right?
Yeah.
Which is practically orchestrating statement, kind of like a durable actor type thing, which practically owns the resource and implements lifecycle of a resource. And they expose it as a resource in the Terraform. So they kind of have Terraform up there and in the middle. It's kind of the layered cake. So you can kind of talk to these workflows as resources, and workflows talk to Terraform as a kind of activity. So they have very interesting kind of way to look at that.
That is
And
very
for example, Netflix, they initially wrote their version of Spinnaker on top of Temporal, but now they completely removed Spinnaker and Kubernetes because it didn't scale for them. And they just orchestrate the infrastructure directly using Temporal, practically directly orchestrating EC2 instances. And I think they thought it's the best model. So it's very common for us to be kind of, there are a lot of companies, some of them I cannot name, which practically build their infrastructure around the orchestration and Temporal, because you can both have processes which are guaranteed to execute and resources which are practically these always running workflows. And these are very powerful abstractions.
No, that makes total sense. And I do recall that big announcement from Netflix that they were moving away from Kubernetes. I can't remember exactly if it was a year or two ago. And everyone started taking at face value, saying like, "Oh my God, Kubernetes is done," and which was kind of an interesting reaction.
They're not done. They will be for a very long time, no question. But certainly, then Kubernetes wasn't created. Obviously, it created from Google, but it's a separate project. Google internal infrastructure scales infinitely, right? Like Borg is, I've been at Google, so Borg does scale. But Kubernetes is a completely separate project, so it has abstractions, but it never was built to run on like infrastructure of the size of Netflix. And they put a lot of effort trying to make it run, and they couldn't. And they found that their fork was too heavy to maintain. And Temporal does scale infinitely. So that is a kind of biggest difference, that when you use Temporal, you need to think about scale. You just we know that we just throw hardware that it will scale.
Yeah,
For example,
exactly.
like just another example, OpenAI, every image you generate for OpenAI is a temporal workflow, right? Because an OpenAI scale is immense, right? And because this technology does scale.
Yeah, no, I totally get it. And I could see how images is the perfect candidate if you wanted to run, for example, like stable diffusion like processes on top of temporal, then give guarantees of execution. I'm really curious. You mentioned cloud. We've touched upon cloud versus open source a couple of times. I'm really curious about how you think about those two motions, right? You clearly have successful companies that have built on top of your open source project, and you also have very successful companies that have built on top of cloud. Um, I'm really curious from your perspective how you see those two play with each other, almost as a founder who is always on that debate in my mind as well.
There are like a lot of reasons. I think one of the reasons why you absolutely have to have open source. First, my personal belief is that if you're an infrastructure level company,
Yeah,
any real infrastructure level software should be open source.
very interesting. That's a hot take, I assume.
Because no company will use practically depend on the technology which is proprietary for their like fully depend on that. And if you look at that, like all real infrastructure which people run on, right, is open source or has like practically at least. Obviously, you can have proprietary components, but it's open source. And it's one thing. And just even logically, imagine that temporal kind of forces you to rewrite your code as durable execution. It completely changes your architecture. Which means if you rewrote your code using durable execution, you cannot just go and walk from that. You're kind of locked in. It's obvious. It's a much better world, but you are kind of using that. So
Yeah,
imagine we build proprietary technology. Everybody uses that, and we all practically cannot walk out, right? And no company will ever do that. Okay, maybe startup does whatever, but no real corporation would never do it. So practically having real open source, not like toy open source, like this kind of
but yeah,
not really working, but just kind of working single machine solution is not like it's not an option. We absolutely should have real open source projects, which is again big companies can run and they trust that it's actually fully sold. We even have multi-region replication, multi-cluster replication as part of open source, right? So it's a fully featured, and we also provide. And in the cloud, what we are doing is we are practically just doing better version of that environment. Not okay. Just start from the beginning. What temporal is from architecturally. There are libraries in every language. We talked multiple languages. They're just libraries. Like if it's Java, it will be practically normal library which you include in your Maven file or Gradle. If it's like Go, it will be just a package, right, in the GitHub. So you include that library in your application. You compile against our library and deploy as part of your application. Temporal in both open source and the cloud. Cloud is probably not the best name we actually pick because it kind of implies running your code. We don't run your code. It is a
got it.
SaaS service, right? And so you run your application on your infrastructure using your deployment methods. It's part of your service. And then there is a backend component, the same way there is a backend database or there is Kafka cluster, right? And there is temporal cluster. And this temporal cluster has gRPC interface. So your library needs practically connection string to the gRPC interface to the store state and read state. And so that cluster, so when we say temporal cloud, all we are talking about running that backend cluster, right? You still run your code, you still run on premises, you can run it anywhere. All it needs to connect, and it's one-way connection. You need to connect to that cluster. If you're enterprise, you almost always run through a private link, right? Because you don't want anyone be able to use your connection.
No, of
And
course.
then there are two other things which are important. Like first, I said, you run your code, you connect to the cluster. And another most important thing is that temporal is not a database. It doesn't need to look in your data. So what it means is that you can run encryption using your keys and your algorithm on the client. And temporal cloud cluster never sees anything in clear text, right?
I
And
guess it doesn't need to exactly.
right, because it's passed through. And what happens is that, like I've had this conversation a million times, and now every salesperson Temporal had this conversation that you go to any company and they're like, "We love the solution, great, we are going to use open source. And besides, we don't want to run it, but we cannot because PI customers, we are like all the kind of thing, And when we explain these things to the security team, they're like, "Oh, okay." And we pass security reviews for largest companies in the world. and
Yeah,
the banks
exactly.
and whatever, because they just understand that this is, if you trust your encryption, and in worst case scenario, then you need to pass data for Temporal, can pass just pointers to your data in Temporal. That cloud. The way we practically convince people to use us, because we just provide much better operational experience. Our cloud scales better. It's running in multiple, like, I don't know, probably 15 right now, 14 AWS regions. We run on GCP, we will run on Azure at some point as well. And we can just operate it much, because we almost always end up in the critical path of your business.
Yeah,
And
yeah,
people just don't want to depend on kind of solution which they run themselves, because we can just operate it much more reliably. And what happens usually is that people just give us one local workload, run for some time, and then they, almost every customer who ran kind of on our cloud and open source ended up migrating to cloud, because they just think it's cheap. And we are match price. It's actually not more expensive to run on the cloud, because we have very optimized persistence.
yeah.
We can actually, even us making some margin, we still can give you a price which is either better or comparable to the running it yourself.
Well, and there's the R&D of doing it yourself. And I think the way that you explain it to me, like I can think from a CIO or CTO perspective, that first instinct, if you don't know how it works, the first instinct is like, oh, no, no, we need to run everything on premise. But once they realize that, no, you still run your code on your infra, but like we become this like orchestration and you can use pointers. I think it makes total sense. It reminds me a little bit like we use Porter, for example, for deploying. And Porter, I mean, I don't know if you know Porter, but they basically just allow you to deploy EC2 instances and like pretty quickly, and it's still running on our infra, right? Like, and so we would never want to run Porter inside like on prem because there's no need to. Like, it kind of defeats the purpose. This has been amazing, Maxim. I feel like I've learned so much already. I'm really curious about what's next for Temporal from a tech, from a community perspective, from a product perspective.
So community is, we are super excited, because community has been growing exponentially since we started to measure it. So last 5 years, it was like 7 to 10% month over month
That's
growth
amazing.
in all metrics we have. And it's getting even better, I think, right now. So we certainly not ubiquitous yet. We want to get to the point when everybody,
Of
because
course.
our goal is everybody knows about durable execution. Everybody knows about temporal, then they can make a decision to use it, not to use it.
Yes,
But
yes, yes.
reality is that after you know about that, you want to use it. And yes, so I think community is our huge asset. If you want to just check it out, just go temporal.io/Slack. And we have, I don't know, 17,000 people now in our Slack, maybe
That's
more. I,
amazing.
I didn't check for a while, but it's, you can ask anything. You can just talk about technology. So just join it, please. And we want to do more things. For example, we still don't make it easy to contribute, because it's a pretty complex project.
Yes, of
We
course.
want to add things like extensions to be able to kind of extend product from outside, more like plugins. There are a lot of kind of ideas we are playing there. And obviously with things like Nexus, like building the whole like long running services and exposing to others. So there are a lot of interesting things which we can do there. In terms of product, there are a lot of things. Again, Nexus is one which we are extending to all sort of connectors and being able to call different APIs and different services. Like just most basic thing, like just trying to explain what you could get with that. Imagine we write generic connector to any RPC service. And then you can be able to call this RPC service reliably, and we will do all the retries as long as you want. You call it,
Interesting.
and we can make it long running call from a workflow or even from outside and get webhook call when this retry is complete. So it's down, we retry for a day and then it comes back, we will do webhooks and done. And you don't need to write workflows, you just write Nexus and use a gateway for that. But then you can do all sorts of interesting things there. And then there is the whole agentic world when we are trying to integrate with different frameworks. Because if you have framework which does code, you can just write temporal code. You integrate with framework, like you can still can use framework, right? But
Yeah.
you don't have to just use these graphs and other kind of weird ways to specify your business logic, and just write normal Python, Go, Java code to orchestrate those calls to agents and whatever. And there are a lot of kind of areas there. And then, yeah, integrating with MCP and other technologies would be, I think, a lot of value there.
I'm really excited about MCP, honestly, because it came out nothing ago. And I feel like we're already learning a lot about resource discovery. I joke with our colleagues here a little bit that MCP reminds me of Waddle in a way. I don't know if you ever worked with Waddle like years and years ago. It was this like resource discovery protocol to be able to discover new like REST
Okay.
endpoints.
I was never a big fan of XML, but I had to deal with that for a while. Yeah. Remember I talked about this mapping engine, so I was able to map any XML structures to, I don't know, whatever other uh, Corbett generated structure.
Yeah.
Yes.
Wow, well, Maxime, thank you so much for this. I really, really appreciate it. I personally think this is one of our most technical episodes. I feel like the audience is going to take a lot of it, and I'm excited for you guys. What's coming? There's so much happening right now in the industry, and I feel like honestly, I'm excited for Temporal because just philosophically, it makes sense for the industry. So, thank you so much.
Thanks a lot. Bye.